Urania. Urania is the goddess of both weather and of astronomy, or goddess of the atmosphere, actually. She has quite a wide-ranging set of responsibilities, and so it's very fitting that I'm able to put them both together in this venue. We're going to cover a bit of ground over a number of years out to 2013, but I want to talk about the annular and the total, the transit of Venus, and some notes on the November 2013 eclipse coming up primarily over Africa, as I've just returned from some scouting trips there. Here is the path of the annular in next year in May, beginning actually very close to the Vietnamese border and ending in Texas, both places that have a lot of history and in fact linked history to some extent. You can see by this track that the coast of China, coast of Japan are well within the track. The Aleutian Islands in Alaska have been missed. And so it spends a great deal of its time over water, and land-based opportunities are really divided into two parts of the world, either on the eastern or the western side of the Pacific. The track across the western part of the Pacific the center line is always flirting with the coastline, sometimes inland, sometimes on the coast. And it passes through some fairly large cities along the way, in particular Hong Kong, Taiwan, and Guangzhou. And later on, when we get a little farther north, Tokyo is virtually right on the center line. It's unfortunate in a way that crossing so much population that the weather prospects are not particularly good at this time of year. The monsoon is already well established in the southern part of China and is moving northward, not quite into Japan, and so we have a little bit better weather prospects in Japan than in China. When you look at this graph, which I've made up here, these are a number of locations along the track, Hong Kong here, and then places in Japan on this side. And you can see that the two critical cloud cover categories are this red one, which represents the probability of overcast skies, and this dark purple one, which is broken skies. And broken cloud is cloud that covers half the sky or more. So primary, or the best eclipse viewing weather is actually in these three categories of clear skies, a few clouds, which you see is 1 to 2/8, or I've reduced it to a fraction, or scattered clouds, which is anywhere from 2 to 4 octas, as we say, or up to half the sky covered. So these are pretty good conditions for seeing the eclipse. And you can see that inland in China, these three favorable regions are quite small. They get a little bit bigger when you get into Hong Kong area and then deteriorates again. And for the most part, if you're close to the coast, you tend to have a little bit better weather. In Japan, the two categories are here, and you can see that there are some sites that have a little bit more favorable conditions in these wedges, but pretty much all the same. They only vary by a few percentage points. These numbers here are actually an average that I've calculated showing the average cloud cover. Hamamatsu here is probably the best place in Japan that I was able to find, and it's comparable to Hong Kong, which is one of the best places on the coast of China. When we get across to the other side of the Pacific, we find quite a variable terrain in here. Whereas Japan and China are roughly rolling hills, a fairly rugged terrain, but not very high. Once we get into the western part of the United States, we have quite a large area of mountainous terrain through here with some fairly significant peaks in it. Some of the highest peaks along this coastal mountain range here, and then on the other side, with a broad plateau in this area, and also a little range of mountains and high hills right as we come ashore where the eclipse first reaches land again. Then once we get to the end of it, we're onto the flat Great Plains of the United States, although just barely. This zone in here is a zone of thunder showers, and in this region, at this time of year in May, the thunder shower season is not quite underway. So we quickly just look at these maps. You can see how we have low, flat terrain here. We have a valley in here around Redding in California. We hit higher ground in here. We get into the flat plateaus of Nevada through here, but with some valleys in it. Valleys are actually favorable. The lower the land, or places that are lower down in the mountains, tend to have better weather than places that are on the windward side of the peaks. Once again, when we get into the Utah, Arizona border area here, we see a valley that sticks up through this place called St. George and so on. But it's a very narrow valley up in here. And the wide one is likely to have better cloud cover conditions. And again, through Albuquerque, a number of people are thinking of Albuquerque because it's a pretty big city, easy to find accommodation. But it has mountains on both sides of it, and these are pretty substantial. I've driven through those on a number of snowstorms, and although May is a little late for a snowstorm. Flagstaff is interesting just outside the boundaries of the Eclipse because, of course, it's an important astronomical site for the old telescopes that used to study Mars. Albuquerque, because it's in such a narrow valley, doesn't get as much benefit from being lower down and tucked in between the peaks. Finally, when we get out into New Mexico and cross the border into Texas near Lubbock, which is right here, we're into the low sun angle pictures here. This is a very favorable area for weather. You're now coming downhill. The winds that blow from the Pacific are coming downhill in that region. And I know after the talks yesterday, many of us have been thinking about being somewhere between about here to be able to see that eclipse right on the horizon. When we look at the same cloud cover graphs, right away we see that there is much less broken and overcast in selected places in the United States than there is in China and Japan. And so the area that we like is this blue, dark blue to light blue area, fairly small when you're on the coast because there is a lot of cloud cover along the coast, primarily fog at Eureka, California. Redding, which was in that valley that we talked about, all of a sudden we see as soon as we get into that valley along the California coast, the amount of good sky conditions really improves. Even in Reno, Nevada, which is now in the plains, or the high plains, we see that about half of the conditions of cloud are favorable for eclipse viewing. And so it goes, you can just look at these numbers, 40, 29% when we get to the Grand Canyon. A very, very nice place to watch the eclipse if you want to put a lot of scenery in with it. And the eclipse will be low enough that you should be able, with a wide-angle lens, to be able to show the canyon and the eclipse at the same time. Probably the best place I've found is Window Rock in Arizona. You can see the amount of clear skies is enormous, a few and scattered, and the only unfavorable conditions tend to be in that tiny wedge here. I'm showing an average cloud cover of 9% there. And again in Klein's Corner in New Mexico. But you see in between these two lake locations, and these cloud cover graphs follow along the eclipse, there are places where it gets fairly cloudy, so you have to pick your site carefully. When you put those numbers together and show the average cloud cover, you can identify where these good weather areas are. The Sacramento Valley here, and particularly Oroville, which is actually a little off the center line, but represents some of the northern part of the track conditions. We have the Mojave Desert here, the Kaibab Plateau, and what's called the Llano Escado, which is the plains of Texas and New Mexico there. So in those locations is where you're going to find your best conditions. And you just have to go to the maps on my website, on Google Earth, and just find those locations on those plateaus and pick your poison, so to speak. Here's a picture of just a typical day, May 21, 2006. You can see the kind of cloud cover that you have over top of that region and all these holes in it. Some of them, this one here, represent holes that are caused by the airflow over the mountains and down into the lower terrain. When we get across Arizona and New Mexico, skies are pretty clear because they have a very nice dry climatology. And when we get into Texas, this is a line of thunderstorms that is just starting to form in that area. So if you can't go eclipse chasing, you can go storm chasing, because this is one of the world's best storm chasing areas in here. And another picture from another year, and again, now we have Nevada and the plains open. Still some openings in the cloud where this cold front is going across the mountains. Another area of thunderstorms forming here, but clear in New Mexico and Texas in the best areas. So you have to pick your position, partly from climatology and partly from looking at the weather forecasts. But this should be an eclipse that if you're mobile, it's easy to find an opening in the clouds. We get into the eclipse, the total eclipse for next year, we really only have one choice on land, which is in Australia. We have, I know of one ship in this area, which is sailing from Hawaii to Sydney, and there will be some ships offshore in here. I don't know if there's anybody else in this region, and this is actually a good region to be in. We look at this cloud cover map, and I've made this pretty high resolution. Blue colors represent the sunniest areas, and this is an average of 20 years of cloud cover from satellite images. So you can see that offshore of Cairns, which is right in here, that the weather is actually slightly better. It's sort of in the average cloud cover approaching around 40%, something like that. Also good along the Gulf of Carpentaria here. But over land, the monsoon season, the wet as the Australians call it, is starting up in that area, and so the average cloud cover is a little heavier. In fact, it gets quite heavy when you get up to the start of the track, and again on land here. But there is a dry area. I was expecting that anyway, so. That dry area that sticks up through the outback of Australia is actually a pretty good place to go. And the one thing about these cloud cover charts, there are a number of ways to measure cloud. And you can have a day which is completely overcast, but where the sun is visible all the time. The cloud is so thin that you can't, it doesn't cause you any problems. For an eclipse chaser who wanted a deep corona, it would give you a problem, but you would be able to see the eclipse through it. The satellite sees that cloud cover as overcast. And so these cloud cover maps are much more pessimistic than the real situation. Now, I can also generate cloud cover maps, and I think I'll put them on my webpage, that show opacity, the thick cloud, the cloud that will block the sun. And you'll find that when I do those maps and compare them with each other, the actual frequency of thick cloud is about 30% less than these pictures of cloud amount. Unfortunately, people that observe from the ground only observe cloud amount. They don't observe opaque cloud, except for one country in the world, and that's Canada, the only one that tells you how much cloud there is that's actually blocking the sky. So you can't take these cloud maps as gospel. You have to take them in relative sense, so relatively sunnier in here than on the coast. You can see this heavier cloud right in here. This is the cloud that builds on the mountains in that region. This map is for the afternoon cloud cover, and of course we have a morning eclipse. So this drier area up in through here tells us that getting over these mountains is probably a better area to be in Australia if you're going to maximize your potential. Unless, of course, you can be in a ship that's out in this region or actually quite a long way along the eclipse track offshore. The reason for all of this is sort of average pressure pattern in Australia. And so we have a low pressure system here, which is the beginnings of the wet season, and we have a high pressure ridge on average. But these are average conditions. The weather is always changing. Systems are coming ashore in Australia all the time, and so you can't rely on them except to explain why the pattern is the way it is. Some of the cloud conditions, there are two numbers I like in here. This one is the probability of, the percent of possible sunshine. So that means judging or based on the number of hours per day that have sunshine recorded compared to the number of hours that you would have if it was sunny all day long. So Darwin, where the eclipse starts, 66% of the days, or of the hours if you wish, in November are sunny. We can see that as we go down the eclipse track, that increases to 74. We get at Cairns, we have a 66, some of the locations offshore. Unfortunately, only a very few stations measure sunshine. Most of them measure cloud. Here we are with all the categories of cloud. We won't go into them. What I want to look at is this average cloud cover here. And you can see we have an average of 55% at the start of the eclipse, somewhat higher as we get to that Gulf of Carpentaria. Then it drops. So we have Palmerville so low that I'm a little suspicious of it. But nevertheless, quite a long period of records showing 33%. Palmerville is in the interior of Australia along the track, right in about the middle there. And as we get to Cairns, we see we have 50% in here, and then some of the offshore islands are actually showing a little bit heavier cloud cover. I don't think they're completely representative of the cloud cover because the cloud in Australia is very sensitive to whether you have land or water. And so even small islands tend to have a little more cloud than if you were on a ship there. Just looking at the terrain, and Terry and Joe are going to talk about this a lot more. But Port Douglas here, there's a good road that gets you up into the junction, and then you can get around behind the terrain and go northward. I like to be behind these really big peaks, and these are big peaks in here. So you have to get a long way behind them along this road to sort of be out of any potential cloud, because the moisture is going to come along. It blows in from the ocean. It's going to strike these hills. The cloud builds very, very quickly in the morning, but usually it's a little subdued overnight. We have a gap in here where the air can blow through that gap and carry moisture from the ocean, but at the same time you don't have the high terrain to make it build into clouds quite so much. So I sort of have scouted this Weatherby station in here, which is not in the best location, but there is enough of a line of hills in front of it that it will take some of the moisture out of the cloud. Here's a view from Port Douglas along the waterfront, just to give you an idea what those mountains look like. This was a sunny day when we were there, and that particular year Australia was very, very wet, so you're going to see pictures that are actually more pessimistic than the average conditions. But this gives you an idea of the kind of viewing locations that you might be able to pick. Of course, the beaches will be very popular. To watch, if you were to watch from the hills here, then you run into the danger of the air that blows up the hills and over them is going to create cloud. So you'll like to get behind those a little bit. Here's what the terrain is like in the interior, and again, I'm not going to say much other than you're a bit challenged to find a view of this very low sun from that kind of a perspective. With all of these trees in the way, everything is being blocked. And here's that junction that I talked about again, looking in the opposite direction. But Terry and Joe Calley will tell you more about it. Here's a picture of Weatherby Station at sunrise, or just after sunrise. Sort of, the sun has to clear the hills, so the eclipse it would be up about this high. Turned out there was a power line going right through there from this location, so this farm you have to move back farther on the hills. I believe Travel Quest is going to use this as one of their locations for. But the clouds, even though it was a heavy cloud day, the clouds are broken up a little bit in the early morning by the flow off the mountain, and because of the fact that these clouds are not usually heavy clouds just to begin with. Here's some pictures of from this year. So they're recent, and you can. This is Cairns right here, this little promontory that sticks out. These are visible light images at a time. This one's 2033 Greenwich, and these two are. Or this one's 21. 20 wasn't available. So this is approximately eclipse time. You won't be able to see these pictures on eclipse day because this is right at sunrise, and the hour before it was too dark to see anything. But you can see this line of cloud along the coastline here. That'll be moving toward the coastline. Here we see some clear area along the coast, but more lines of cloud offshore. These lines of cloud are very, very common, and then a sort of heavier mass of them. I think because of the shape of the coastline here that area between Cairns and Port Douglas is actually slightly favorable for lower cloud amounts. This is what you'll see on eclipse day, is these pictures from the Australian Bureau of Meteorology. We'll be talking to them about giving us more magnification so they look more like this, but you have to try and make your decisions on where to be in this based on this very low resolution image. And it is possible to get higher resolution images, and I think that'll probably happen. So you'll have to plan if you're going to move on the basis of these, and you can look at these and compare them to the ones up here to see just how visible the cloud is. It's actually, this line of cloud here is extremely difficult to see along that coastline. You have to really be careful and probably enhance the images to see them. Here's a little bit of a movie. You can see the sun coming up. The eclipse is right at the start of this movie, but you can see how this trade wind flow in here and out of the southeast is endemic along that coastline. Cairns is right in here. These are the beaches here. So you're going to have a great deal of difficulty. You can see that this cloud offshore right at the start is sort of eclipse time, and very quickly, an hour later, is onshore. So it could be quite dodgy finding an opening in the cloud, particularly with the fact that we're going to have a marathon going on at the same time. There's a La Nina going on right now. I expect that it won't last, and it probably won't be El Nino conditions. But if there is, this is a map I've made up that shows that there's about 5% less cloudiness, 5 to 10% less cloudiness during El Nino in that part of the world. We go to the transit of Venus. We've already seen this slide from my webpage, and the favorable areas are these ones that are brown colored, so Australia, the coast of the United States, Saudi Arabia, and the Sahara Desert area. The potential sites, actually, Hawaii here is there's a little bit of lighter cloud between 4 and 5/10 average in Hawaii area as well. It's hard to say whether or not you should plan on these too much, because this is a 6.5-hour event, and you could probably drive 300 kilometers to find an opening in 6.5 hours. But the critical moments are just as Venus is going onto the sun and just as it's coming off, because that's when you see the most interesting phenomena. Here's a little higher resolution cloud cover. You can see I've put India at the top here, and it'll be no surprise to you that the best conditions in India and the lowest cloud cover is actually a little bit to the west of Delhi here. In Delhi itself, the monsoon, of course, is coming in from this direction and wrapping around through the Bay of Bengal. So the mountains along the Pakistan, or the terrain along that Pakistan border, has the least amount of cloud at this time of year. And this is for all of June. We are early in June, so you could assume that this is probably a little bit backed up, and that Delhi is actually not in a bad position for watching the transit. In Australia, there's no doubt where the best area is, probably, except for the Sahara, the best on the globe. In the United States, very good conditions, exactly the same place that we were recommending in the annular eclipse are also good in June. The monsoon season is beginning in here, so this is a little bit dicey right in the New Mexico, Texas border area. And of course, Hawaii, the big island right here, which is just barely able to see the whole of the transit, but the islands a little farther along the chain are better. And it turns out that you're better to be on the west side of those islands than on the east side of those islands. You get about 10% less cloudiness. It's just a typical picture from June of last year showing the sorts of conditions clear across most of the southern and western United States, of course clear across Australia. India was probably in a pause in the monsoon at the time. Looks like some kind of the remains of a cyclone going ashore here. So the area that was supposed to be sunny is not, and the area that's supposed to be cloudy is. So you always have to use your weather forecast. Here in Hawaii, we can see sort of general cloud conditions, a little more cloud on the east side of these islands than on the west side. This is a challenging eclipse because these gray and dark green areas represent very high cloud amounts, between 7 and 9/10, or more than 9/10 even when you get into the thickest part of it. So we have to kind of select carefully. We're an annular eclipse in this part of the track, so almost everybody's going to be wanting the remainder, and of course it's only the latter half of the track that gets onto land. Maximum eclipse is right here in this area, and that's actually in a lower cloud area than along here. This is part of the intertropical convergence zone, and it gets a little bit of a break here because you occasionally get winds that come off of the Sahara that tend to erode the cloud. And so climatologically, this is a lighter cloud area by about 10–15% than other places. I know of one ship that's going to be right at the maximum point here, and I believe that another one from Wilderness Travel is going to be slightly back in this area. Once you get on shore, high cloud levels approaching the more than 90% average in Gabon, 80 to 90% across both Congos, and it's only when you get into the eastern part of Africa where the eclipse is very short that you start to get into a lot of, or some prospects of better skies, at least on average. So I've given a little bit higher resolution on this chart. So you'll see this plug of cloud in here. There's some kind of a convergence in this region on this promontory that causes cloud to form in this area. And I think it's partly a convergence along the ITCZ, the Intertropical Convergence Zone, and partly just the clash of flows between the drier air from the Sahara and the moist air that's over the equatorial regions. Nevertheless, when you look at this chart, there are three regions that stick out. This one here in Uganda, this one in Kenya, and of course at the end of the track in Ethiopia. Now that this part of Somalia is part of Ethiopia, somebody might want to go right to the end of it, but I don't think that's going to happen. In Gabon, there's one interesting point here at Cape Lopez where you can actually go to Port Gentil and travel north 2 kilometers inside the eclipse zone and get a 1 minute or nearly 1 minute eclipse. It is possible to go from Port Gentil by boat over to this region. This is a flat terrain. We were warned that if you do that, you should send somebody who knows the area ashore first to check for animals. That's a region where you get hippopotamus that do surfing. They go out on the beach and into the ocean, and they're very ornery. Another place might be to go down here into, this is a pretty big city in here, and so Lamborghini has got a fairly long ride, but it's a good highway up north to the central region. Once you get into Congo-Brazzaville and the Democratic Republic of the Congo, it's especially in the DRC, which has got a low-grade civil war going on, you probably wouldn't want to go there. But Congo-Brazzaville is also a possible area in there, but it'll be for only small groups. Look at the cloud cover. Here's the average monthly rainfall through the year. It'd be nice if we were at this time of year, but we're not. We're in this time of year, so we're actually in one of the rainy seasons. Most of these regions have 2 rainy seasons during the year. So we're a little bit challenged, and you can see percent of possible sunshines in the 30% range. The E here means estimated from a larger chart, 30 to 40%, and the calculated cloudiness is kind of gruesome, mid-70s up to just over 80%. But this Lamborghini here has sort of at 70%, it's one of the lower ones. So it's big thunderstorm climatology, and when you have thunderstorms, you always have an opening in the cloud somewhere. So the 3 regions we like are these 3 in here, and these are the ones I've just finished scouting. Just to give you some idea, here's satellite pictures from 4 different years. Here's these regions. This is Uganda, Lake Turkana, which you can see in here, and Ethiopia. This would have been a good year in 2010 for all of them. Here we are in Gabon, challenging, especially on the coast, because that area of high cloudiness on average is actually very deserved, because very frequently you find these clusters of thunderstorms there. So we go to the next, this year, 2011, some openings in there that might let somebody get lucky. Uganda looks good. Kenya looks really challenging, and Ethiopia looks really challenging, although there are some breaks in it. And these are taken pretty close to eclipse time. 2009, Gabon looks like it's a dead loss, and it's not really good in 2008. Uganda looks good, Lake Turkana looks good, Ethiopia looks cloudy, and in the next year, these 2 are good, Uganda isn't, and once again, Gabon is not. So you can see right away, just from 4 years, that Gabon is not the first choice as far as weather's concerned, and that the other 3 are kind of up and down, and they share in a little more sunshine than farther to the west. Here are the statistics, and you see instead of 30s now, we're into 50s and 60s, and at Lodwar, there's an 80. Lodwar is just outside the eclipse by about 30 or 40 kilometers. Kind of they call it a western town in the sense of the old west of the United States. So that looks like a pretty good area in here, and the calculated cloudiness in Uganda, 70, they're pretty high, down to 71 in, well, closest place to my clear weather area in the satellite is this one, which is showing a gruesome 85. I don't like Gulu, but I think that's too high. Look at the annual rainfall. All of these have either 1 or 2 peaks in rainfall, but this is Lodwar's rainfall, and these are all on the same scale. So even though they have the same pattern of rainy season and a dry season, the amount of rainfall is very, very much less. So I like Lodwar as my best site for weather along this eclipse track, but you get an 11-second eclipse there. Uganda, not quite so good, but you get 18 seconds of eclipse. And Ethiopia, which is also probably the second best site, you're down to 8 seconds of eclipse. And so Uganda, the place I like is right in here. Got the hills to take some of the moisture out of the weather that's coming through. And this is in that zone where the average cloud cover was lower. And this is a picture out of the center line. It actually goes through the marketplace in Pokwero. You probably wouldn't want to set up there. You won't want anybody around when you've only got 18.7 seconds of eclipse. We did some, here's a picture that looks to the west. It was a cloudy day, but this is a pretty thin cloud. It was bright. You can see shadows on the ground, and you would have been able to see an eclipse that day. But the satellites would have told you that it's overcast. We also ran into, some of the roads we tried were not very good along the way. Lake Turkana is interesting. Lodwar is here, which has got the lowest amount of cloud. The eclipse track is here. There's a fishing village here called Kalakal. There's a park here, Siboloi Park, and there's the park headquarters right there, 2 kilometers north of the center line. And it actually has a longer eclipse there than at the center line. Here's the view from Lake Turkana. This is looking from the east side, park headquarters area. Very flat terrain. There's no obstructions whatsoever to any kind of eclipse viewing, except, of course, if it's a cloudy sky. On this day it was, on this one it wasn't, even though you do see thin clouds there. We already have some eclipse chasers in position, so some people are getting an early start to it. Park headquarters are here. There's accommodation for 4 people there. There's a crater lake just south of the eclipse track right in here, which is worth a visit if you can get a boat over to it. A nice little island with an old volcano. This is from the west of the center line, from this area right in here, looking toward land. Again, you can see that it's very flat, but it's also quite marshy and not a good one to be in. So climate, everybody says that it's always sunny in Lake Turkana, very low precipitation, but you can get some very, very bad weather there, and there's quite a bit of evidence of some very severe flooding at some time in the past when we were there. You can't really get on the shoreline of Lake Turkana. It's in the delta of a river that's sometimes flowing and sometimes not. And when you get off the highway in that area, and if it's been wet, you probably can't travel on the roads. The last place here is in Ethiopia. Yabelo is probably the closest big city. It's about an hour-and-a-half drive down. There's a little town here in it. This is sort of what the terrain looks like at the center line in our scouting trip. The road is good. The hills are rolling. This is a picture in the direction of the eclipse. It would be somewhere up above these trees. Well, of course, you have freedom to move. This is Madacho, the town that's in the eclipse track, and they now know that, although I don't know what they'll be doing about it. Along the way, you do get into some higher hills that could cause a problem, but the eclipse track is only 15 kilometers wide, so you're not likely to be tucked behind mountains on it if you go to this site on the center line. You get a lot of convective clouds, showers and thunder showers every night, every day, every afternoon. They dissipate fairly quickly and then they reform again at night. But it was sunnier than I expected, and that's partly the problem with the way the satellites measure cloud cover. So I'm going to put all of this material and update my website, especially the 2013 information, and there's the address for it and my email address. If you have questions, you can come to me for it. And the other thing to recognize is that when the eclipse starts, I'll have a section in my webpage which will take you very, very quickly to weather information that you might need when you're on site in the eclipse zone. So there'll be access to computer models that predict the cloud and to satellite imagery and anything else. And I'll do what I can, but I expect to be on a ship during that eclipse, so I'm probably not going to be able to send out forecasts too regularly. So thank you very much.